Picture this. You walk into a massive factory, but it's pitch black. The lights never even need to be turned on. Yet, all around you, machines are moving with absolute pinpoint precision. And get this, there are absolutely no shift changes.
Zero lunch breaks either, seriously. There's no cafeteria, there's no break room. The assembly lines, they just never stop.
And absolutely no weekends. Production just keeps going, relentlessly, 24/7, assembling products and adapting to new tasks with barely any humans in sight. Now, for decades, we've treated this like pure sci-fi. But today, this lights-out, continuous production is rapidly becoming an actual, on-the-ground economic reality.
So, welcome to The Explainer. I'm super thrilled you're here with us today because we're diving into something huge, the massive global race to develop humanoid robots. We're going to unpack the data, look at the billions, yes, billions in investments, and really dig into the massive stakes for global labor markets as these machines start coming online.
All right, Section 1, Sci-Fi becomes economic reality. Let's get right into it.
Right now, across the globe, billions of dollars are fueling a massive paradigm shift. You see, we're finally moving away from those traditional industrial robots we've known for years. You know, the ones bolted down inside cages, just doing the exact same rigid task over and over again. The new frontier, it's humanoid. We're talking about machines custom-built to navigate environments that were originally designed for us. They can walk through standard doorways, climb stairs, and actually use general-purpose tools. It's a total transition from rigid, single-task machines to highly adaptable ones.
Which brings us to Section 2, why humanoids, why now?
It's a totally fair question, right? Because honestly, engineers have been experimenting with walking robots for decades. But let's be real, those early models, they were way too expensive, incredibly slow, and honestly, just too unreliable to make any sort of economic sense. The math simply didn't work. But suddenly, a massive technological convergence has completely flipped the equation. Modern robots are benefiting from tech that literally didn't even exist a decade ago. We now have these advanced cameras and depth sensors, giving them incredible sight. We've got powerful AI models that allow them to actually recognize objects and, get this, understand spoken instructions. Toss in highly efficient electric motors, way better batteries, and cloud computing that lets these robots share data and learn collectively, and boom. Suddenly, instead of rigid, hard-coded programming, we've given robots a flexible learning brain.
And it really all boils down to this one simple equation. Adaptability equals economic value. This global race we're seeing, it is absolutely not about building a cool walking science project. It's about building a general-purpose machine that can generate real, tangible economic value. Being able to adapt to a chaotic, ever-changing environment, that is exactly what's pulling in astronomical investments from giants like Tesla, Figure AI, Boston Dynamics, and huge players in Asia. They see these adaptable machines as the absolute future.
Okay, let's move on to Section 3, the future of the workplace.
So, where are these super adaptable machines actually going to end up? Well, they're heading straight into sectors that are currently battling severe labor shortages. Take manufacturing. Humanoids can step right in to transport materials, assemble components, and tirelessly inspect products. What about warehouses? Thanks to the massive, never-ending e-commerce boom, they can flexibly sort inventory and even move entirely loaded shelves around. And healthcare is huge too. They aren't replacing your doctor, but they are safely lifting patients, transporting vital supplies, and delivering medications. It maps out perfectly exactly where these robots can jump in to keep our vital production and services running smoothly.
But wait, let's look at Section 4, roadblocks to widespread adoption. Before we all assume a fully automated world is happening, tomorrow morning, we really need to ground the hype. We have to face some pretty harsh economic and physical realities first. The absolute biggest hurdle? It's pure finances. Companies are pouring billions of dollars into this technology. And since businesses always evaluate automation based on ROI, return on investment, these robots have to deliver massively. To justify those billions in purchase prices and ongoing maintenance, they basically have to drastically reduce expenses, significantly boost productivity, improve safety, or perfectly solve those labor shortages. It's a very tall order.
And beyond the money, well, the engineering itself is just staggeringly difficult. Think about the sheer physical intelligence required here. First off, they have to master constant bipedal balance. I mean, just walking on two legs is an incredibly complex physics problem for a machine. Then, their hands need to precisely manipulate thousands of different, totally unpredictable objects. And above all else, they have to operate safely right next to us. A robot that looks amazing in a carefully controlled YouTube demo, but completely fails in a chaotic, messy, real-world workplace, well, that's economically useless.
reliability matters every bit as much as intelligence. Which leads us to our final part, Section 5. Will robots take your job?
Naturally, all this rapid development leads to a massive, very valid concern. Are these things going to eliminate millions of jobs? Well, if we look back at historical precedent, previous waves of automation didn't actually end work, they just fundamentally changed it. Think about it. Mechanized agriculture dramatically reduced the need for farm labor, but it actually birthed the entire manufacturing industry. Then, industrial automation transformed those factories, but it created brand new careers in logistics and maintenance. Personal computers automated office tasks, but they sparked entirely new digital sectors. Humanoid robots represent this fourth major wave, and history suggests they're highly likely to follow a very similar pattern of disruption and creation.
Now make no mistake, routine physical labor will absolutely face major disruption, and communities dependent on those jobs could face some very real challenges. But on the flip side, we're going to see a massive surge in demand for entirely new roles. We're talking robot technicians, AI engineers, safety specialists, system integrators, and software developers. Education and specialized workforce training are going to be absolutely crucial here, as the demand literally explodes for workers who can manage and maintain these complex automated operations.
The broader economic implications of all this are just staggering. Why? Because higher productivity has historically been one of the absolute strongest drivers of long-term economic growth. Ultimately, if these intelligent machines actually become affordable and reliable, businesses could produce so much more with way fewer constraints. And consumers, we could directly benefit from lower costs, massively improved services, and entirely new business models built completely around robotic labor, maintenance, and software platforms. It's a real game changer.
As artificial intelligence and robotics converge like this for the very first time, making general-purpose humanoids commercially plausible, the future of work isn't going to be determined by the robots alone. It's actually going to be shaped by the choices that businesses, policymakers, and all of us workers make right now. So the ultimate question I want to leave you with is this: will we merely replace human labor, or are we going to redefine exactly what humans can accomplish? As these intelligent machines become our powerful collaborators, perhaps the greatest opportunity lies not in replacing ourselves, but in discovering what we can achieve together. Thanks so much for joining me for this explainer, and keep exploring the future.